All right, may as well start. Go ahead and add anything to the agenda that you guys want to discuss. First thing up is Corey about the multi-delete PR.
Yeah, thanks, Casey. So let me put the link in Etherpad too, in case you don't have it. So that's the PR that I initially opened a couple days ago, and the idea for that one is just make the multi-object delete individual objects concurrently. Right now, I have it spinning off every single individual object within the request onto a new coroutine and trying to do them all in parallel. But as Casey just commented on it, we do need some kind of limit for the async, the number of coroutines that we spawn off. So I did want to talk about that a little bit, but it looks like based upon your comments, you had a similar idea to what I was thinking. Probably add a new configuration parameter to have some limit for the number that are spun off at any given time for this particular request type. And that way they can either fall back by setting it to 0 or 1 to do them all synchronously as it is now, or have up to whatever asynchronous level they want. Does that does agree with what you were thinking, Casey?
Yeah, I don't necessarily know that it needs its own config variable,
Yeah.
but I guess that would be consistent with what we've done elsewhere. So whether you want to make it configurable or not, I think is up to you.
Okay. It seems like it would be nice to be configurable from my side because we'll probably want to play with it when we start using it for quality of service purposes, which kind of leads me into the next thing. So our clusters in production are spinning disks for the data pool, and we use erasure coding with 8+3. And so with all the right amplification from the erasure coding and trying to do, in this case right now with the PR, I'm allowing up to 1,000 at a time since there can be up to 1,000 individual objects within a multi-object delete at once. It has a huge, it basically has a huge number of IOPS that it's inducing on the cluster, and we're opening up to just allow our cluster to be slaughtered basically by these multi-object delete requests. And the underlying thing that we need to be able to get to a few thousand deletes per second for multiple tenants at once, basically. We're not going to be able to get there as long as the hard drives need to be involved in every single delete. And right now, that's basically necessary, it looks like. So the other thing that I'd like to change and I would like to discuss is the idea of having another configuration object to prevent RGW from storing any data in the head object and let that only be the metadata, so that the delete operation part that has to be done synchronously and that can't be part of the GC chain can all be on the NVMEs, because we have our DB walls all in NVMEs, and then we can make that scale really nicely. Thoughts on that?
Let's see. So yeah, I think that could be configurable. This reminds me of some discussions from, I believe it was a developer with Intel, Anthony. Sorry, I don't remember the last name. Yeah, that sounds right. They were looking for a way to control placement of the head objects as well.
I have a simple change already that I'm sort of testing at the moment, and it's quite easy actually, since you guys already have like some objects that don't have data in the head, like for the multi-part and for the append type objects. And so it's a pretty simple change, or small change at least, and seems to work pretty well for us. We haven't tested it in production yet with actual NVMEs, but it should allow us to scale to like hundreds of thousands of deletes a second, whereas right now we're getting like 50 on this type of cluster. So it would be a huge performance improvement for us.
Yeah, another interaction is with storage classes. I don't know if you've looked into those, but any objects that are uploaded to a non-default storage class don't store any data in the head object.
Okay.
That stuff is configured through the zone placement, and so maybe it would make sense to have a flag or something there to disable storing data in the head.
So are you saying that it's already possible if you configure placement groups in a certain way? Or no?
Well, I don't think that's exactly what you want. Like by default, all of the objects are uploaded to the default storage class where they would store data in the head. It's only if there's another storage class that's not the default, then we put all of the data in its tail objects instead.
And you mean default for the bucket? So it'd be like on an individual bucket basis?
Yeah, there's a global default, which is just the name standard. And then on a per bucket level, you can configure different default storage classes.
Okay.
I think you can do that per user also.
Okay.
But the configuration for that stuff lives in the zone placement. And so rather than doing like a Ceph config variable, which might not be the same on all RGWs, I think the zone placement would be the place to control that.
Okay. So other than that, I guess I just wanted to make sure that I kind of gut checked my understanding of why the data was co-located with the head object in the first place. And it's, I think, just because it reduces or eliminates one extra Rados call, especially for small objects. Obviously, it could double the overhead if you make two versus one. Is that the whole idea, or is there more to that?
Yes, basically the code calls it prefetching. When we look up the head object, we'll also read the first chunk of data. So that's like one round trip that we can avoid otherwise.
Okay. Yeah, and I think that's okay for clusters like ours because the metadata would still be really quick, since that request would be served from the fast storage, and then the penalty wouldn't be huge, I guess, for gets and puts, and it would make a huge difference for deletes. Okay. Well, I think that's all I had in terms of discussion on that. I'll probably open up another PR related to that piece, and also add a commit for the QoS type stuff on that existing commit here today or tomorrow, and then we can discuss it more on GitHub. Thank you.
That sounds great.
Thanks, everybody.
Any other thoughts on this? Any other discussion topics?
Yuval, you want to just chat now?
Yeah.
Yuval wanted to talk about something related to the perf counters work I was doing. I don't know.
This is no. I just wanted to have like a sync up. I don't think this is part of this meeting.
Oh, okay.
Okay, well, I'll wrap up and stop the recording and you guys can discuss what you want. Just a final couple of reminders. Ceph Developer Monthly is tonight in the Asia Pacific time slot. And then the virtual Cephalicon starts tomorrow. I think the first talk is tomorrow, and you can see the schedule on the link in the Etherpad. Thanks, everybody.
Thanks. See you.
Thanks.
See ya.